Underground uranium mining is, in principle, not different from any other hard rock mining. And indeed, other ores are often mined in association with uranium, for example, copper or gold or silver. However, particular attention to the ventilation of the mine is required to limit dose to the workers from radioactive radon that's emitted from the uranium decay daughters. Once the ore body has been identified, a shaft is sunk in the vicinity of the ore veins, and crosscuts are driven horizontally to the veins at various levels, usually every 100 to 150 meters. Similar tunnels known as drifts are driven along the ore veins from the crosscut. The next step is to drive tunnels known as raises when driven upward and winds when driven downward through the deposit from level and level. These raises and winds are subsequently used to develop the stopes, where the ore is mined in the veins. The stope, which is the workshop of the mine, is the excavation from which the ore is extracted. Two methods of stope mining are commonly used in the cut and fill method and open stoping methods. The space remaining following removal of ore after being blasted is filled with waste rock and cement. In the shrinkage method, just sufficient broken ore is removed via the chutes below to allow miners to work from the top of the pile to drill and blast for the next layer to be broken off, eventually leaving a large hole. Another method, known as room and pillar, see the picture, is used for thinner, flatter ore bodies. In this method, the ore body is first divided into blocks by intersecting drives, removing ore while doing so, and then systematically removing these blocks, leaving sufficient pillars for the roof support. In situ leaching, ISL, sometimes is referred to as in situ recovery, ISR, or solution mining, is performed by pumping liquids, either weak acid or weak alkaline, depending on the calcium concentration in the ore, down through injection wells placed on one side of the deposit of uranium, through the deposit, and then up through recovery wells on the opposite side of the deposit. By this, they can recover the ore by leaching it from the rock in the ore body. ISL is also used on other types of metal extraction, for example, copper. ISL is often cost-effective because it avoids excavation cost, and it may be implemented much more quickly than conventional mining. However, it's not suitable for all uranium deposits, as the host rock must be permeable to liquids, such as is the case with sandstone. In situ leaching is the only type of uranium mining currently being done in the United States as of 2006.